time so I can take attendance when it's due. So make sure that you fill out that attendance form that I will link to Canvas, and then, like I've always done. And then separately, I'll probably just have a little bit of practice for what we're doing today, just to bridge the gap to next week, because we have next Monday off. The 18th is Martin Luther King. So I won't see you until Tuesday. But before we get into the new stuff, I just want to reiterate some things that we talked about from yesterday. I saw almost everybody has filled out that Google form that I posted yesterday, and I think I reposted on today's announcement, I think, for making your first kind of unofficial selection for next year. For those of you that are going to be juniors or seniors. So I want to make sure that you try to get that done now, even if you're not sure what that best class is for you. Or at least sometime really soon, because I want to go in and check to see who wants some guidance. So that if you like make your first choice, you think, all right, I think I want to take stat reasoning, but I'm not sure. And so when you answer that form, the last question, you say, yeah, I would love some guidance. Can you reach out and talk to me? That's what I want to do between tonight and during the day tomorrow when you guys are doing your thing, but I'm not having to hang out with you guys live. I can start to answer those kind of questions one by one. So if you have asked for my help, one way or another, either you reached out separately or you answered yes to that Google form, I'm going to send you a message on Canvas, and we can start that dialogue back and forth. And it might take a few messages back and forth to kind of get you to making the best decision. But here's the thing I want to make sure you know. If you've already filled it out and you change your mind, great, okay? I just want you to then fill out the form again, if you can. Now, either way, when we get to Wednesday next week on registration day, I'm going to meet with every single one of you individually. I'm going to drop you into individual breakout rooms where you're going to sit and wait, and I'm just going to bounce from room to room to room to room, making sure I have that one-on-one conversation with you to get that final decision. I'm going to write it down, and then we'll be good to go. But if I have an idea of what you think you want, and we can have the conversation before that, then that Wednesday can go really quickly. Okay, I don't want to have you sitting there waiting for a half hour if we can avoid it, so or more. So fill out the form if you haven't, but realize that it's unofficial and it's just a first selection, and that if you want to change your mind, you can change your mind. You can change your mind again and again and again until we find the best class for you for next year. Okay, because I'll just pick your most recent submission, right? Because it tracks email addresses, and I ask for your first and last name anyway, so I can just delete. You know, if you fill it out 3 times, I'll just delete the first 2 when we finally get to like Wednesday. I'll go through that. Okay, so if you haven't done that yet, do that, but know that nothing of what you've made is set in stone. Okay, and then Wednesday's schedule is a little different than usual different Wednesday schedules. Next Wednesday, they're going to drop homeroom. They're not going to do homeroom instead. What they'll do is they're going to front load that time, that half hour or so at the beginning of the day, so they can prep you for registration, okay? There's a video that counseling has put together on what registration looks like this year and how to do it and blah, 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 that your first period teacher is going to show you. If you don't have a first, go to second, okay? For me, like I don't teach a first period, but I do teach second, so I know that on my Canvas page from my second period class, which is my calculus class, I'm gonna put a link for 7:40 or whenever that first class starts, so I can show that video. Okay, cool. So that's that. I just want to make sure I mentioned a couple of those things. But open up that dialogue with me, because if I don't know you want my help, then you're I don't know. Right now I'm not going to help you. So answer yes to that last question, or like a lot of people have done. I've gotten dozens of messages so far already. Rosie, what should I do next year? Or these are the classes I'm thinking about. Tell me more about them, or what kind of things am I going to learn, or who might be teaching it, or I want to be this after high school, or I want to do this after college, or I want to join this part of the military, or I want to do that, whatever. What do you think is best? Like those kind of questions is what I'd love to hear. Okay. All right, cool. So that's that. Any registration questions now? I'm looking down at you guys now that I've said that. Hopefully not. Hopefully I've said more than enough. Usually that's me. All right. I want to teach you something different. I feel like factoring we've done pretty well. I didn't look at 2.3c yet, but when I looked at 2.3b, saw a lot of good stuff, which was awesome. So hopefully that stuff is clicking really well for you. We'll definitely need that when we get to the end of chapter 2. because we'll test ourselves on this for sure. I want to get you a correctness grade for some of this stuff sooner rather than later. Maybe remote, but maybe once we get back to hybrid. I always like doing stuff in person so I can help you in the moment in case that stuff comes along. But we are going to keep moving on. I'm going to skip 2.4 for now. We're going to come back to that once we do 2.5 and 2.6. So no tests anytime soon, like week or two. No, probably not. We've got more to do first. Okay, so we're going to be in 2.5. So take us on the right with something to write on. But I'm going to do it a little differently. Instead of teaching you something brand new and adding to your quadratics stuff that you're trying to organize in your head, I would rather show you how to use knowledge you've already got and how to use that to deal with issues that we run into. Okay, so I'm going to take a slightly different path on how to teach you what shows up in section 2.5. Because we still get to the same setup and then we can solve it the same way. It's just kind of the in-between. So like, let's say there were 3 steps to this problem, okay? I'm gonna mess with step 2, okay? Step 1 is gonna be the same. Step 3 would be the same if we were doing this their way. I'm gonna mess around with step 2 because you guys already know how to do that. It goes back to last semester, but we did that recap over those first couple days. So I'm gonna lean on some of that stuff. That we know right there. So I'm going to write down the title of this section, but only just for your edification. We're not actually going to do it necessarily their way. Okay, so it's called to complete the square. Okay, but we're not actually going to do that. Okay, the process is similar, the end result's the same. So why not use what we already know how to do and just build on it? Okay, so that's what I like to do. The idea here is that we run into a problem trying to factor, right? They're giving us something in standard form. We want to find the x-intercepts. Listen, if it's factorable, I'm always going to factor. That is by far the easiest way to do this, at least for me. Now you might look at today's stuff and be like, oh no, I like that way. Let's do it that way all the time. Because what I'm about to show you works no matter what. Right? Factoring doesn't always work because I can't always add to this and multiply to that. Numbers don't always work perfectly together. This way, guaranteed to work no matter what, which is kind of cool. And maybe you like that. Now, we're going to need to factor. Right? Maybe the problem just says, hey, here's a quadratic. Factor it. Well, I can't use this way because this isn't factored. Okay. But the idea is to give you options, and this option always works. But I'm going to work with you today on ones that just aren't factored. But even if it was, it would still work, okay? So the idea with completing the square, or at least solving for x-intercepts this way, I'm not really going to complete the square, is like, what if the quadratic is not factored? Okay, and what if we want to find those x-intercepts? Because I can draw parabolas that don't necessarily hit the x-axis in nice spots. Because that's what factorable ones do. They hit them in really nice spots. Well, I don't have to hit the x-axis at 2 and 4 or -3 and 5 or even like 1/2 and 2/3. Like those are nice spots, right? Integers or fractions of integers, factor. But what if I had not so nice spots, like decimals that go on forever, that kind of bounce around, there's no pattern to them? I want to show you how to do that. And so here's my plan. So I'm going to come over here. I'm going to write down a little how-to for those of you that like to have the steps written out. Okay, how to find the x-intercepts if not factored. Okay, obviously that's not great grammar there, but I'm trying to keep it short and sweet. Cool. Now, what's basically going to happen for us is they're going to give us some function, right? They're going to say f of x equals x squared plus blah, 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 blah. And the question is, where does this thing hit the x-axis? Okay, so I don't know. I'm just going to make it up. So call it number 1. Let's say they give us a quadratic like x squared plus 4x minus 7. And so it starts in factor form, right? So in a second here, that'll be number 2. I'm gonna write something down for number 1 real quick. Two numbers that add to 4 and multiply to -7? Mm-mm. 1 and -7 or +1 or -1 and +7, neither of those add to 4. So this thing isn't factorable. I can't solve that diamond problem or the plus, blank, blank plus blank and blank times blank. I'm gonna come down here real quick just to show you what I'm talking about. Like this quadratic is not factorable, right? And I'll show you what that kind of looks like. I'm just gonna share my screen real quick. I'm gonna graph something in my calculator super fast. Right, y equals x squared plus 4x minus 7. Okay. All right, it's got a vertex. Cool. It's right. Let's see, where is it? There, -2, -11. It's got some x-intercepts, but those are not nice, right? And remember, this is just being rounded. These numbers go on forever. That 1.317265490, whatever. It's gonna keep going, which means I can't factor it, which kind of makes sense because I can't add to 4 and multiply to -7. But I still have answers, so there should be still a way to find them, okay? Now, look at these x-intercepts. So what's that y value for both? 0, right? Which kind of makes sense because we're always kind of dealing with that. I'm going to stop presenting here for a sec. So you guys can come back up. That's always what we want to start with, right? Whenever we were factoring these kind of things and we wanted to find the x-intercepts, so over here, number 1, always, 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 if they ask you to find the x-intercepts, set that thing equal to 0. Right? Because y is 0, and that's what I want to do. But, all right, so like we're starting in standard form. But look at that equation, right? X squared plus 4x minus 7. I've got an x and I've got an x squared. And if I'm trying to get x by itself, if the idea here is to just like, add, subtract, multiply, divide, square root, whatever, to try to get x alone, if I've got an x and an x squared, I can't do that. And that's why factoring was so nice, right? We ran into that situation where I couldn't solve it, but if I could split it into 2, then I could put the line down the middle, set them separately, equal to 0, and do my thing separately. Well, this I can't factor. And so we're gonna have to do something else. I've gotta go from this ax squared plus bx plus c kind of setup, and I've gotta go and try something else. I've gotta do something different. I can't leave it in standard form and actually solve it. Now, if it was factorable, that's always the way I'm going to go. But this isn't. And so we've got 3 forms of quadratics. Standard form, no good, not going to help. Factored form, not even possible. What's the other one? If you remember, unmute yourself, give us a shout. What's the other way that we can write a quadratic that's not standard form? Say that again.
F of x.
So like I can put the f of x in front for sure, but like I want to like rearrange the way this looks. F of x for sure, but now I'm setting it equal to 0. So I don't even want the whole function. I just want the x-intercepts. Good thought though. I just want to like, I don't want the ax squared plus bx plus c kind of setup. I want the other one. I want the one that only has like just x. Like I only want one x in the whole equation because that I can solve for. Like remember back to chapter 0, I don't care what the equation looks like. If there's only one missing piece, I can go get it. If that's what we spent a month on trying to get a whole lot better at. If I can rewrite this like those kind of problems, then I can solve for it. So standard form, no good. Factored form, not possible. What's the other one?
Vertex.
Vertex form. That was 2.1, right? We found that if we had this a, x minus h squared plus k kind of setup, look how many x's are in that whole thing. Just 1. And if I only have 1, I can go solve for it, okay? Now, that means, like, all right, if I want to like write it in vertex form, I better find the vertex first, okay? Because we've got a, which is going to be the same. So I know over here, like, okay, a is 1, right? There it is, cool. But like B and C being what, 4 and -7, like great, that's not gonna work for me written like that. I gotta get that HK, I gotta find the vertex. So that's what we're gonna do. We're gonna go from standard form to vertex form, which you already know how to do. How do we do that? First, we find the vertex. Okay, if I can find the vertex, then I'll just write it, right? And maybe you remember this, maybe not, but remember the x value, so h is just -b over 2a. And if I can do that part first, so I'm actually gonna like kind of separate my work right here. If I can come off on the side and find the vertex by doing that -b over 2a, and then I will just plug it in, then I'll just drop h for h and k for k, and then I'll have this same equation. So I'm gonna mess with this left side. All right, I'm just gonna rewrite this, but in order to rewrite it, I gotta find the vertex first. So that's what I'm gonna do. I'm gonna say, all right, I'm not even gonna say x equals, I'm gonna say h equals. Okay, because that's the number I'm looking for. And I know that I don't care what these numbers are, if it's in standard form, it is guaranteed to be -b over 2a. Okay, all right. Let's do it. Let's find -b. Well, so b is 4, cool. So I just need -4. Remember that negative really just means the opposite, right? Switch whatever sign you got. Starts positive, cool, we'll make it negative. If it starts negative, we'll go back to positive. Okay, so there's b, nice. And then 2 times whatever a is, okay, a is 1, awesome. Well, so we've got -4 over 2 times 1. All right, let's take care of that denominator because we've got some things to multiply. I'm keeping a1 for today just to make things a little simpler, but a can be whatever. And factoring is a lot harder to deal with a. Vertex form, really easy, and you'll see that next week. Okay, 2 times 1 is 2. So I know that h is whatever that fraction is. And if that fraction was gross, I would just leave it, right? If it was some decimal that just goes on forever, I'm just gonna leave it as the fraction, right? If it was a nice decimal, I don't care which one you use the fraction, use the decimal, but -4 divided by 2 is -2. Sweet. There's h. That's the number that's gonna go right here once I'm ready. Okay, but I still have to plug this thing back in. Let's see what I get. Okay, so I'm gonna go back in, I'm gonna say, okay, I got x squared plus 4x minus 7, right? So that -2 is gonna go there, and right there, -2. So that's k, I should say like k equals, my bad. K equals, I forgot something. -2 squared, whatever that is, plus 4 times -2, whatever that is, and then -7. And you can do this all in one shot on the calculator. I do not need to see your arithmetic. You do not have to go step by step by step. Don't forget the parentheses though, because negatives are gonna get screwed up in the calculator if we forget them. But if we did this step by step, I would just follow order of operations. All right, exponents first. -2 times itself, okay, +4. +4 times -2, okay, -8. And then bring down to -7. So there's k. 4 minus 8, -4, -7, -11. And when I showed you the quadratic, that's where the vertex was. If I pulled that screen up again, if I pulled up Desmos, man, I love Desmos. If you looked at my internet history, it's probably like 80% Canvas, 20% Desmos. We saw that spot, right? And so we're there, cool. And if I know h and k, then what I can do is I can rewrite the left side, right? So there it is, in vertex form. Because if I can do that, rewrite the left side in vertex form, I've got one equation that's got one x, and all I have to do is solve for it. Okay, so that's what I'm gonna do. So this is still equals 0. Nothing about the right side changes. It's just the left side that I rewrite. I'll drop a in for a, h for h, and k for k. Well, a is just 1, and so if I put like 1 parentheses, multiplying by 1 is not going to change anything. So just like I leave the 1 off right here, I might as well leave the 1 off right there. What's the point in multiplying by 1 or like eventually dividing by 1? Nothing's going to change. Okay, cool. X minus, and hold on a second, don't write this just yet, minus -2. Don't write that. Why put two symbols next to each other? What a waste. That's going to mess up when I'm trying to undo stuff. You've got two negatives next to each other. Put them together and make a plus. So x plus 2. That looks way better. All right, don't forget the squared. That's everything. That's the whole point. This is quadratic. I need power of 2. Okay, and then a plus k. Again, don't write this yet, but plus -11. What a waste. Two symbols next to each other? No, put them together. You got two symbols that are different. That is subtraction. There we go. Now we're ready. So we had a little bit of that side work to do. A little bit, right? I know it takes some time, for sure. Factor if you can. I think it's way easier than this, but this always works. Now, let's solve. Solve for x. How do we solve for x? We take order of operations, and we go backwards. We are going to undo what's happening to x, getting ourselves to the point where we can get to x equals whatever it is. Because if I can get x alone, what have I found? The x-intercepts. And that's all I want to do. I want to find those pesky, weird x-intercepts that didn't work out so nice. So, now we're ready. Let's do it. All right. So I start at the bottom. Any addition or subtraction that's by itself. This is not by itself. That plus 2 is trapped inside by that exponent, which means I cannot subtract 2 from both sides. Can't do it. I gotta break that plus 2 out of that squared before I'll ever be able to mess around with it. But that little -11 hanging out by itself at the end, that I can start to move away. The idea is to undo what's happening to x by doing the opposite. And there's my middle, right? There's my equal sign. There's my balance. I got to start moving stuff from the left side to the right by doing the opposite. You've got a -11, opposite of that is +11. All right, so when I do like my steps, I'm going to write them in blue, okay? My new version of this equation, I'll write in red, okay? So left side is going to get a little bit simpler. Right side will get a little more complicated as we start adding stuff over there. So cool, +11, so 11. These are gone. That's the whole idea. Get stuff out of there. Haven't touched any of this yet, so I'm just going to rewrite it. I'm going to slide that down. X plus 2 squared. And I don't know why, but sometimes I write my 2's like this, and sometimes I write them like this, and you can see my unconscious brain switched them. Oh, sorry about that. I'm a dyslexic math teacher, figures. Cool, done. Addition, subtraction, good to go. Okay, so I start at the bottom and I just go step by step by step, doing the opposite. Okay, so I took care of any addition, subtraction that I could. Again, can't touch this yet. If there was an a sitting right here, now would be the time where I would divide it away, right? Because it's a times whatever. But this is the 1, so I don't have to worry about it. But if it was a 2 or a 3 or a 5 or a -6 or whatever, divide it away right now. But I don't have to. I'm good. A little check mark there if you want. Multiplication, division step done, because I didn't have to worry about it. Okay. Now exponents. That's what I got to undo, right? I've got this power of 2 right here. I got x, whatever, plus 2 squared. I want to hear from you guys. What's the opposite? Like the opposite of subtraction was addition. The opposite of multiplication was division. What's the opposite of squaring something?
Square root.
Yeah, nice. Okay, so that's what I'm going to do to both sides. Now you could just like draw the square root over the top if you want to save yourself some space. But I'm gonna rewrite it with the square root on top, just so you can see it. So I'm gonna like draw the square root like this. I'm gonna draw the square root like that, and I'm gonna keep the red stuff underneath because I really haven't done anything yet. I'm just showing you what that step looks like. Okay. Now the square and the square root are there to cancel each other out, right? Just like the plus and the minus or the multiplication division. So the only thing that I have left on the left is the x plus 2. And since the thing that was attached on the outside of the parentheses is now gone, I don't even need the parentheses anymore. So cool, x plus 2. All right, square root of 11. Can you guys think of a number that if you were to multiply it by itself, if you were to square it, you would get 11? Let's see, 1 squared is 1. 2 squared is 4. 3 squared is 9, so we're getting closer. But then 4 squared is 16. So it's got to be some number between 3 and 4. But like, what is that number? What are we supposed to do if we've got this square root and we can't think of what that number is?
Keep it the same.
We got to see what it is. And then if it's ugly, yeah, we'll just keep it exactly the same, right? So I'm just jumping into Desmos right now. Oh, come back. Oh, what are you doing? Oh, there we go. So I want just this. That's all I wanted. Keyboard. Square root of, hide this, 11. So I'm going to jump in the calculator. All right, square root of 1 is 1. Square root of 4 is 2. All really nice numbers, right? Square root of 9. So square root of 9 over here, right? 3. Decimals I love. Square root of 11. Yuck. Right? Some decimal just keeps going on forever, and there's no pattern to it. And I don't want to round, right? I don't want to stop this thing early because then I'll be off by a little bit. So when I have these square roots that are just not perfect, the idea is that we don't change anything about it. Square root of 11, cool. Square root of 11, it is. But, and here's a big important thing that we want to remember. We just took the square root. If we square root, so I'm writing this over here too, but I'm going to put it over here. Obviously, I'm just going to leave it as the square root of 11. But that square root wasn't part of the problem to begin with. We just did it. Right? We introduced the square root to this problem. Flashbacks to a while ago. What do we need in front of that square root to remember that there are possibly 2 x-intercepts? What do I need to drop? And I'm going to drop it right here. And the very first time I see it, what do I need in front of that square root to keep track of 2 answers? It's been so long. I'm going to hide. Somebody remember? I'm going to be so proud. What goes in front of a square root? I don't care if it's nice or ugly, like this one's ugly. Square root of 9, square root of 16, whatever. What do we put in front of a square root so that we can keep track of 2 different answers?
Plus or minus?
Yes, nice. I love it. So good to remember. Plus or minus all the way down. It never disappears. Okay, plus or minus. So if we square root, we need plus or minus that square root. So critical, because otherwise we'd only get one answer. And I want both of those x-intercepts. Nice, good. All right, so exponents and radicals done. But we're not quite there yet, right? I got to get to x equals. That's my goal. So I want to get down to that last answer. You see my equal signs are starting to drift a little bit because my right side's getting a little busier. Now, finally, I'm inside that square root. Inside the parentheses, sorry. I'm inside the parentheses. I'm finally inside that grouping symbol, right? I called it GEMDAS, and then I called it GERMDAS, right? Because a lot of different ways to group numbers together. In parentheses from like plain old PEMDAS from middle school, it's still there. But now that I'm inside, now I can finally go back to the kind of the bottom of that and start taking care of that plus 2, of course, with a minus 2. All right. Here's the problem, though. That 11 is buried under that square root. And I cannot just magically subtract 2 from that. Because that would be the square root of 9, which would be 3. And I would get plus or minus 3. And obviously, those are not the x-intercepts. It was like negative 5 point something and 1 point something. So how do we write this? If I can't put the 11 and the negative 2 together, you can write it one of 2 ways. Okay, I'm going to give you the way that might seem easier, but it's not super nice to write it like this because the ugliness is first. first with the plus or minus the square root. Read this out loud to yourself, like going straight down. Plus or minus square root of 11 minus 2. Okay, plus or minus square root of 11, stop the square root, minus 2. Perfect. Nothing wrong with that. Okay? You want to leave it just like that? I'm cool with that. The only problem that I see is that the kind of nasty square root is first. We like to save the nastiness for the end if we've got any. So the version that I kind of like better is putting that plus or minus the 11 at the end. Again, plus or minus goes with the square root. I'm not going to move it to the front. It stays right where it is. Instead, what you could do, hopefully you guys can, I know I might be off screen, but hopefully you can see this. I could put the negative 2 part first and then do the plus or minus square root of 11. This one's nice. So either one, I don't care, whichever one you want. If you want to avoid making mistakes, then go this way. And just the way you would read it out loud is the way I write it down. Some people mess up by like extending that square root farther than it should go. Some people forget the plus or minus. So it's up to you, whichever way you want to go. But bam, there it is. Negative 2. I'm going to come down here for a second. Plus or minus the square root of 11. The reason I'm coming down is I want to show you what those numbers look like. Now I'm just going to do one more, and then we're going to get out of here. All right. So there's two versions, right? There's the square root of 11 minus 2, and there's the negative, so positive square root of 11, and the negative version of the square root of 11 minus 2. Your x-intercepts. 1.317, which is really 1.316624, whatever. They stopped it right here, had to round up that 6 because the next number was 5 or above, right? 5 or above, give it a shove. And then same thing here. Negative 5.31, stop right there. They always go 3 decimals. It's plenty of accuracy. 317. Okay? So those are really, if you have 2 separate answers, we can just write them as one using that plus or minus. That's good. You don't have to split them apart. If the square root was nice, then I'd probably, square root of 9. Oh, it's 3. Okay, so I got 3 minus 2 and 3 plus 2. Well, that's 1 and 5. So I just write those answers down. But it all started right here. All started by figuring out what that vertex was so we can make our way back up or down to the x-axis. Nice, ugly, big numbers, small numbers, doesn't matter. This process always works, which is why I really like it. All right, let's do one more, and then I'll get you guys out of here. I'm going to speed up the process just a little bit. I took pictures of this work from 6th period, so I want to make sure I add that to Canvas for you guys. All right, let's do one more. So I'm going to erase the work that's up here. Again, I will upload the picture so you can see it, but I don't have to erase everything. Just like we do it with the factoring, the setup's always the same. I'm just going to pick a different B, I'll pick a different C. This will change a little bit. So get rid of all this. Nice. That setup's going to be the same. Okay. Negative B over 2a. So those numbers might change. Setup won't. And you're going to see I'm going to deal with some bigger numbers coming up. So I'm definitely going to use a calculator right away. All right, cool. Let's mess with just some slightly different numbers. Let's go x squared minus 18x plus 59. Who cares how big the numbers are? We've got calculators. Let's do it. Okay, so I'll give you a second to write that down. This one's number 2. We'll do it together again. I'll give you maybe a couple to try tomorrow to see if you can do it, right? We'll probably come back Tuesday and have to see it again all together. I'm cool with that. And I like to take time. So A is 1, B is negative 18, and C is 59. You see, we don't really need C in this case because the vertex is just a negative B over 2A. But it's always good to kind of get in the habit right next. Okay, set equal to 0. Done. Set up. Nice and good. And once I set it equal to 0, I know I'm looking for the x-intercepts. All right, it's in standard form. And so I look at those numbers and I say, all right, can I add to negative 18 and multiply to 59? God, how do you multiply to 59? Well, Like you go through it and you go, all right, divided by 1. Okay, so 1 and 59 could work. That's never going to add to negative 18. Numbers are too big because both my numbers are negative because I got to add to a negative and multiply to a positive. Divide by 2, no. Divide by 3, no. Divide by 4, no. Divide by 5, divide by 6, divide by 7, divide by 8, divide by 9, divide by none of them work. 59 is prime. The only way to get there is 1 and 59. So it's not a factor. And I'm going to try, because if it is, I'm going to use that. But if it's not, this is a great way to do it. And if I can just figure out where the vertex is, if I can figure out h and k, then I'll rewrite it in vertex form, and I'll just solve for it. Do whatever I need to do to get it by itself. So I'll do the whole negative b over 2a thing to start. I'm going to find the vertex first. Okay, b is already negative, though. B is negative. I want the opposite of that. So up top here, I'll switch colors. Positive 18. Okay, negative 18, back to positive, right? 2 negative, positive. On the bottom, 2 times whatever a is 1. Okay, keeping it that way just for now. We'll start messing with a being bigger next week. Why not? Okay, so 18 divided by 2. 18 divided by 2 is 9. Perfect. But because the x value of my vertex is so far away, that's why this number is relatively big, just to keep my answers close together. So I could have picked whatever numbers I want, though, but I wanted to pick a big number, just because who cares how big it is? We've got calculators to help us out. Because now what I do is I drop it in. Okay, so I've got x squared, so 9 squared minus 18 times 9 plus 59. And I am not going to sit there and try to multiply that stuff out in my head one little step at a time. I am going to my calculator and I'm dropping that whole thing all at once. Okay, and I'm going to get negative 22. I did this one last time. I did not just do that in my head. Although 81, negative 81, always just changes signs. It's kind of crazy. Cool, negative 22. So there it is. There's k. I've got h. I've got k. That's all I need. Right, because I know what a is. So this 1 that's sitting out here, it's there, but why bother, right? Why write down something like 1 times and like force ourselves to divide by 1 where nothing's going to change, right? Drop it, right? X always. And I need something to solve for, so we better stay x. Now, x minus h. Okay, x minus 9, cool. I don't have to worry about the double negatives, messing with stuff there. Plus k, so plus a negative 22. So I'm not going to put plus and negative next to each other. Let's just do the minus 22. Step 1 done, set it equal to 0. Step 2 is kind of where all of the prep work goes in, right? Find the vertex and then write it down, make it look good. Step 3 is the algebra that's going to get us there, okay? Get x by itself. Right? Start at the bottom, work your way up, kind of undoing things that are happening to x. So all of the left side is where all the action's going to happen, and things just kind of get moved over to the right. Addition and subtraction first. Again, I can't add 9, right? Kind of buried within those parentheses with something big attached to it, but I can deal with this negative 22 by doing the opposite. Add 22 on both sides. Cool, nice. So steps in blue, kind of new versions of the equations are happening in red. So right side is now 22. These are gone, which is real nice. So I kind of bring down the x minus 9 in parentheses squared, and I slide it over so it's a little closer to that equal sign. Sweet. Again, if there was an a here, now's when I would deal with it, because it's connected by multiplication, and that's what step I would be moving up to. But it's just a 1, so I'm good. I skip it, right? Good to go. Now I deal with this exponent of 2 by doing the opposite. You guys are totally right. Let's take the square root of both sides, okay? I like to do it separately. I don't always like put the square root on top because then I'm like mixing new equations and the steps. I like to go equation, step of work, equation, step of work, equation, step of work. So I see the balance because if I mess up somewhere, I can find it. Or if my teacher's looking for partial credit, he or she can do a better job. So I'm going to rewrite it separately here. Square root of whatever's on the left equals plus or minus Square root of 22. Okay, so there's my step. All right, there's my step of work. Now I actually write down what happens when I do that. When I do that, square root and square root cancel out, so I'm good to go. I'm gonna check my calculator here for what the square root of 22 looks like. 22, square root of that. Oh, yuck, 4.690415, blah, 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 blah. No way. Plus or minus square root of 22, it is. Making sure that that square root covers everything it needs to and nothing more. I don't want to make the square root go all the way out to here. There's nothing over there, right? But I also don't want to end it too early because then it looks like it only covers the first two. It's got to cover everything. Okay, nice. Addition, subtraction, done. Multiplication, division, didn't have to worry about it. Exponents, done with that radical, that root. Now I can deal with that -9 by doing the opposite, a little +9 on both sides. And there it is, x equals. Okay, and I don't care which version you pick. The better version is to put the 9 first, right? 9, I don't need a plus sign right after equal sign, right? So x equals 9 plus or minus the square root of 22. That's an awesome version, right? Again, extend that square root as far as you need to, but no further. Or, I don't care, x equals plus or minus square root of 22 plus 9. I'm cool either way, making sure that the square root goes to like above the 2, but that's it. Like, don't go over the plus, don't go over the 9, don't go any further than you need to. Ba ba boom. There it is. Done. 2.5, my version of completing a square. Basically, skipping the steps of trickier algebra to get you from standard form to vertex form, and taking advantage of what we already know how to do, which is find the vertex. Okay, that's what 2.1 is all about. There you go. Okay, I just wanted to do those two with you. Again, I will upload pictures of this in case you can't see it as well. I know sometimes it comes in a little blurry, or you wanna go back to that first one that we did because you couldn't keep up or whatever it is. But that's what we're going to do in 2.5. 2.6, we're going to learn a different way to get you to these same kind of answers, whether they're nice or not. In case you are more of a, man, I'm not really great at the whole algebra thing, but give me a formula and I can plug it in, I'll show you how to do that. Okay, so they kind of exist separately to do the same thing. And then you can kind of pick and choose which one you like. I'm good if you are. Nothing to upload. Just check Canvas for tomorrow. An attendance form separately that I'll have due a little earlier so I can take attendance. And then some practice that'll be just due before midnight. Just stuff just like this. Okay, probably just a couple. All right. And then I will see you Tuesday. All right. But check your Canvas inbox for messages from me if you are looking for some guidance on what class to take. Okay, but nothing live tomorrow. I will see you face-to-face on Tuesday, but hopefully I get a chance to chat with you over the next couple days. All right, hit me up if you need anything. Otherwise, have a great weekend, and I will see you on Tuesday. Have a great long week. See ya.
Thanks, Rosie.
Yeah.
Thank you.
Bye, guys.
Appreciate it.
Thank you. Bye.
Bye, guys.